Title: The Footprints That Changed History Forever. The My Gainisefru Forever. In 1978, a group of researchers at Laetoli in northern Tanzania were doing something that paleoanthropologists occasionally do: throwing dry elephant dung at each other. During the ensuing scramble, one of them fell and, catching himself, noticed strange impressions in the hardened ground beneath him. He called over Mary Leakey. What followed was one of the most significant discoveries in the entire history of human evolutionary research: a trail of footprints preserved in ancient volcanic ash, made by creatures who walked upright 3.66 million years ago. The story of Laetoli begins with geology. Around 3.66 million years ago, Sadaman, an extinct volcano in what is now the Ngorongoro Conservation Area of Tanzania, erupted and deposited a layer of carbonatite ash across the surrounding landscape. Carbonatite ash has an unusual property. When wetted and then dried, it sets to a consistency close to concrete, preserving impressions with exceptional fidelity. Rain fell on the ash layer shortly after the eruption. Animals crossed it while it was still soft. Then the surface dried and hardened, preserving the tracks of dozens of species in extraordinary detail: elephants, rhinoceroses, guinea fowl, a saber-toothed cat, various antelopes, and something else, something that walked on two legs, with a heel-to-toe stride, with feet that bore a striking resemblance to modern human feet. The excavation of the hominin trackway, designated Site G, was led by Mary Leakey and her team over several seasons following the initial discovery. What emerged was a trail approximately 27 meters long, containing around 70 individual footprints from what appeared to be 2 or 3 individuals of different body sizes, walking roughly northward through the ash. The largest individual's prints, designated G2, showed a CN01 Furchency to Lee Seerg 2, showed a Seerg to Monfures 2. Stride length and foot anatomy consistent with a bipedal hominin of modest height. A smaller individual, G1, walked side by side with G2. A third intermediate-sized individual, G3, appears to have walked in G2's footsteps, superimposing its own prints on the larger ones. The physical details of the prints were immediately and unmistakably diagnostic. The big toe was parallel to the other toes, aligned with the foot, as in modern humans, rather than divergent and grasping, as in chimpanzees and other apes. There was a well-defined heel strike, indicating that the foot was landing heel first, with the weight rolling forward toward the ball of the foot and the toes before pushing off, the same biomechanical pattern as modern human walking. There was an arch. The gait was fully upright bipedal locomotion, not the shuffling, crouched, slightly knuckle-dragging movement of a great ape walking temporarily on 2 feet. The species that made the prints has never been proven with absolute certainty. No bones were found at the track site itself, but the dating places the prints at 3.66 million years ago, and the only hominin species known to have inhabited this region at that time is Australopithecus afarensis, the same species as Lucy, the famous partial skeleton discovered in Ethiopia by Donald Johansson's team in 1974. The attribution is widely accepted, though not without occasional challenge. What Laetoli proved, in physical and irrefutable terms, was that bipedalism, fully committed, modern-style upright walking, was already established in the hominin lineage 3.66 million years ago. This was earlier than many researchers had expected, and settled a debate that had been ongoing since Darwin's time about the relationship between bipedalism and brain expansion. The brain-first hypothesis had held that our ancestors became intelligent first and bipedal as a consequence. Laetoli made that ordering untenable. The individuals who left those prints had brains no larger than a chimpanzee's. We know this from the afarensis skull record, but they were walking exactly as we walk today. Bipedalism was not the product of intelligence, it predated it by millions of years. The evolutionary reasons for bipedalism are still debated. The most widely supported hypothesis emphasizes the energetic efficiency of upright walking over long distances. On open ground, a significant advantage in the expanding savanna environments of late Miocene and Pliocene Africa, as forests retreated and open grasslands spread. A bipedal hominin covering ground efficiently, hands-free to carry food or offspring, may have had meaningful survival advantages over a quadruped of the same size in that environment. Other hypotheses point to thermoregulation. An upright posture exposes less body surface area to direct overhead sun, which may have reduced overheating on open grassland, and to the freeing of the hands for tool use and other manipulative behaviors, though the tool record postdates bipedalism by more than 1 million years. The Laetoli trackway has had additional surprises in recent years. A second site at Laetoli, Site A, had long puzzled researchers. The tracks there were larger and more deeply impressed, and for decades there was a competing theory that they had been made by a bear walking bipedally. A 2021 study by Dartmouth researchers resolved the debate by building silicone casts of the Site A prints, comparing them in detail to bear tracks, and concluding definitively that they were made by a large hominin, not a bear. This means the Laetoli site preserves evidence of at least 2 populations of hominins of significantly different body sizes walking through the same landscape at the same time period, a finding that has implications for understanding the social structure and population diversity of afarensis. The original trackway was reburied after excavation to protect it from erosion and root damage, a decision that has preserved the prints well. Casts and replicas are held by museums around the world. The site itself is now within a protected conservation area, though concerns about vegetation growth and groundwater damage have led to ongoing conservation work. For all the skulls, bones, and genetic analyses that form the evidence base of paleoanthropology, there is something that the Laetoli prints do that no other evidence can quite match. They show, in direct physical trace, not a reconstruction but the actual passage of individuals who lived 3.66 million years ago. Not their bones, which are fragments of what they once were, but the impression they left in the world, the specific morning they crossed that ash-covered ground, moving together at a pace we can measure, in a direction we can follow, leaving marks that outlasted everything else about them by millions of years. We do not know where they were going. We do not know what they were carrying. We do not know if they spoke to each other or what they thought about. We know only that they walked upright, and that the footprints look, in shape and stride and gait, remarkably like those of a person walking across wet sand on a beach today.